Bright Duty. Every student matters.
Hello children, welcome to the session. In this session children, we are about to discuss about electric switch, but before that let's just recall what all are the things that we have studied. So children, we have studied about electricity. We have studied what was the origin of the word electricity from the Greek word electricus, which meant amber. Then children, we studied about different circuits, right? We studied about different setups and arrangement in which we observed that in which case bulb glows or in which case bulb will not glow. Then we studied about a fused bulb. We studied about the filament of the bulb, right children? And now in today's session we are going to discuss about an electric switch. So children, if we look at the term electric switch from a layman's perspective, it just turns an electrical device on or off, right? That's what we call every day switch on the light, switch off the light, switch on the air conditioner, right? So children, switch on and off means we are turning a device on or we are turning a device off. So have you given a thought children, what do we mean when we say a switch is on? It means that we have completed the circuit and the current is now flowing through the apparatus, right? Only then the apparatus will be switched on, right? The fan will start moving only when it receives the electricity, only when the circuit will be completed, right? So in that case we say switch is on. And if we say switch off the fan, what we are doing? We are cutting off the supply of electricity so that we turn off the appliance, right children? So this is all about the electric switch. But since we have to look at it from the perspective of science, so we are going to study this in detail, right children? So in this image you can observe the different types of switches that are available in the market or at your houses. So children, we use electric switches in our homes to turn on or off the light, fan, a music system, your television, etc., right? And electric switches are used to control electricity, right children? That is what we are doing. We are either supplying it electricity or we are cutting off the supply of electricity, right? Understood? Now children, how do we define a switch? And this question can come in your examinations for 1 or a 2 marker question. So if it comes as a 1 marker, how are you going to write about it? You will write a switch is on off device. What is switch? Switch is an on off device which helps controlling the flow of electricity, right children? And if it asks you, if it comes for 2 marker, it will also ask you about the principle of the switch. So children, it works by making or breaking the circuit, right? So children, we have studied the bulb glows in an electric circuit if the circuit is complete, right? That is, the path is complete, path or loop for the flow of electric current is complete. And if it is complete, only then the appliance will be turned on. So in this case, if we put switch also, what will the switch do? Switch will complete the circuit, that is, it will make the circuit. And if we have to turn off the device, right, what it will do? It will children break the circuit, right? It will break the circuit and electric circuit will break, then current will not flow. Electric current will not flow. Okay children, understood? Let's move ahead to the next topic. So children, we have certain symbols for the electrical components. So children, first of all you need to understand what are the electric components to make the electric circuit. So children, electric components are the things which makes up a circuit, and we have made a lot many circuits in different activities that we have done. So do you remember? We have used a cell, we have used the connecting wires, we used the bulb and again the connecting wires. So the components of electric circuit are cells, bulb, then switches also that we have studied now, switches, and connecting wires. These are all the electric components. So children, just in writing, just like we do in writing, we have shorthand language, right? We have shorthand where we use the symbols or abbreviations for larger words. Why, children? In order to cut on our time, in order to save our time, we use shortcuts. Similarly, children, in science we have different symbols for these electrical components. Like in chemistry, you have studied that different elements have their abbreviations or symbols. For example, magnesium is written as Mg, calcium is written as calcium. So we have used these symbols in order to simplify our studies, right, children? So similarly, in physics, you have certain electrical symbols to represent these components of an electric circuit. So now, children, we are going to study about these components, okay? So let us now move ahead and see. We have this electric cell. Electric cell is represented by, children, two parallel lines. One is the longer line, the other is the shorter line. So children, the longer line represents the positive terminal of the cell. Okay, children, whereas the shorter line, this line is slightly thicker as compared to the longer line. So we can easily identify it as the negative terminal. Right, children? This is known as the negative terminal. Then, children, we have batteries. Batteries are a combination of two or more cells, right? So we represent batteries like this, as we can see by different parallel lines. Again, the longer lines represent the positive terminal, while the shorter and thicker lines represents the negative terminal of the battery. Then how do we represent a bulb? We represent a bulb by representing a filament like this and then covering it with a circle. Right, children? So this represents a bulb. Then we have a switch, children. Switch is represented by these two dots and this key. So children, when there is gap in between, we say that switch is off, and when they are joined, we say switch is on. But we are going to discuss this in detail. Okay, so need not worry about it. Just now, you just remember what all are the symbols for the different components of electric circuit. Okay, children? So children, here now we have a simple diagram for an electric circuit, right, children? It is the first activity that we have done, children. How we did that activity was, children, see, here we are not using a single cell, we are using a battery of two cells. We have connected two cells, right? Now with this battery we have connected a switch. Okay, children? And to this we have also connected a bulb. Okay, children? So you can observe this simple circuit that we have a bulb, we have a battery, and we have a switch. And this is a diagram for our simple circuit. Okay, children? And children, if you have the other diagram also, you can convert it easily into this circuit diagram. Okay, children? By using these different components, by using different symbols of these components. Okay, children? So let us now move ahead. Let us read about this, children. So we had an arrangement for switching on and off of our homemade torch by moving the base of the bulb away from the tip of the cell. Don't worry about it, children. We are about to discuss this activity too. Okay, this was simple switch but not very easy to use. So we can make another simple and easier switch. So children, here we are talking about the activity where we made a simple torch at home using a cell and a bulb. So what we did, children, was we took a bulb with positive terminal here and negative terminal here. We connected a wire by removing the insulation from the edge of the wire and connected the other edge of the wire to the base of the bulb. Right, children? That's what we did. And then, children, we touched this base of the bulb to this positive terminal, and when we did this, the bulb started glowing. And when we took this bulb away from the positive terminal, it was not glowing again. Okay, children? So children, this process where we are taking this bulb closer to the positive terminal, what we are doing, we are switching it on, right? That's what happens when we switch on the bulb, it glows, and when we take it away from the positive terminal, it is turned off, right, children? So it is also a switch, right? But it is relatively complex to use. So children, we are going to make a simple switch, and let us see how we can make a simple switch with the help of an activity. So children, in this activity, what you are going to do is, you will take a thermocol sheet like this, and you will insert 2 drawing pins at 2 points like this. To the first point, you will attach or secure a safety pin like this, children, and you have to make sure that it is free to move, because if you insert one circle of this safety pin to the drawing pin, it will be free to move like this. Okay children, so what we have to do is, now we have to connect 2 connecting wires to the drawing pins, one over here and one over here. So children, when this safety pin is free to move and not connected to the other drawing pin, we say the switch is off. Why? Because there is a gap between the 2 drawing pins, and when this is the case, the electric circuit is incomplete. Right children, and an incomplete circuit, the current cannot flow. So in this case, we say that switch is off. Okay children. Then children, if we connect this safety pin to both the drawing pins, in this case we can say that since this is also made up of metal, the safety pin, it will conduct the current and the circuit will be complete. And if we connect these 2 wires to a bulb, the bulb will start glowing in this case, and we say the switch is on in this case. Okay children, so these are the 2 cases. Now we are going to read it in detail. I hope you would have understood this. It is a really simple process children, in which we have created an electric switch. Okay children, so I really hope you would have understood. This is a really simple way in which we have created a switch. Let us read about the procedure. It will help us recall this. Okay children, so what we have done is, you can make a switch using 2 drawing pins, a safety pin, and 2 wires with a small sheet of thermocol, or you can also take a wooden board children. Okay, so what we are going to do is, the first step is, we will insert a drawing pin into the ring at one end of the safety pin and fix it on the thermocol sheet as shown in the figure. So children, what we have done, we have fixed this drawing pin in one of the rings of the safety pin and fixed it in the thermocol sheet. Now make sure that safety pin can rotate freely, and now fix the other drawing pin on the thermocol sheet in a way that the free end of the safety pin can touch it. Right, we have to make sure that this safety pin can reach over this drawing pin number 2 easily. Okay, so children, the safety pin fixed in this way would be your switch in this activity. So children, this safety pin will be acting like a switch. Why children? We have already discussed, because once it is connected to only one pin, in that case switch will be off because the circuit is incomplete. And when we connect the other end or the other ring of this safety pin to the second drawing pin, in that case the circuit will be complete and the current can flow easily, and we will say in this case the switch is in on position. Right children?
To construct a simple electric switch. Materials required: small piece of softwood safety pin, 2 thumbtacks, 3 plastic coated copper wires with bare ends, torch bulb, sellotape, electric cell. Method: take one of the thumbtacks and to its pin tightly wind one bare end of the plastic coated copper wire. Pass the loop at the end of the safety pin through the thumbtack. Fix the thumbtack in the piece of softwood tightly such that the safety pin can just turn around. Now take the second thumbtack and in it tightly wind the one end of another plastic coated copper wire. Fix this thumbtack in the wooden board in such a way that the safety pin can easily make contact with it. Your switch is ready for use. Now connect this simple switch. Turn the safety pin such that it makes contact with the head of thumbtack. You notice that bulb lights up. It is because the electric circuit is closed and the electric current flows from one terminal to the other terminal of the cell without break. Now turn the safety pin so that it does not touch another thumbtack. You notice that the bulb stops glowing. It is because the electric circuit is broken or the switch is open. Thus, no current flows from one terminal to the other terminal of the cell. Conclusion. From this activity, we conclude that electric current flows only in a closed electric circuit.
So now make a circuit by connecting an electric cell, a bulb with this switch. Okay children, now what we are going to do is the two connecting wires that we have created from this switch, we will connect it to the bulb. Okay. Rotate the safety pin so that its free end touches the other drawing pin. Now children, let us see what happens is, now see children, we have connected the two connecting wires with the bulb and a cell. Right children, so our circuit is complete, and in this case you can see the bulb glowing. Right, and why is the bulb glowing? Because the circuit is complete. You can see that this switch is in on position, right children? And children, there is one more interesting factor. Whenever the switch is on, we call this as a closed circuit. What do we call it? We call it as a closed circuit, whereas in the second case, you can see that safety pin is connected to only one drawing pin. In this case, circuit is incomplete, and so we call it as off position, and this type of a circuit is children called as an open circuit. This is called as an open circuit. So you should not get confused, because most of the students get confused that when switch is on, it means it is open circuit. No children, when switch is on, the circuit is closed, because only when the circuit is closed, the current can flow through it, right? So children, whenever the switch is on, we say that circuit is closed and the current will flow properly and the bulb will glow. You can also remember this with the name. When we say the switch is off, so you can remember it is from O and the circuit is open, right? Now the circuit is open, you can see it is not connected properly. There is a break in the path of circuit. Current will not flow and we call it as switch is off, okay? Electric conductors and insulators children. Okay, so children, up till now we have covered so many topics, and finally we are going to discuss about the conductors and insulators. In the beginning of the chapter children, we have discussed that the connecting wires were covered with plastic coverings or plastic coating, right? We have studied this plastic coating over them. So children, why do these wires have a plastic covering over them? This is because children, the wire beneath this plastic coating is actually made up of metal, right? Most of these wires are made up of copper, right? These are the good conductors of electricity. So whenever we connect them into a circuit, current will flow through these wires, and if they are not covered with the plastic coating, you can get an electric shock if you touch them. But children, since plastics cannot conduct electricity, therefore we have covered these wires with plastic covering. That is why we removed this covering from the edges of the wire before connecting it to any circuit, right children? And now we are going to discuss that these material which do not conduct electricity are actually known as insulators, whereas the materials which conducts electricity are called as conductors or electric conductors. Okay children? So let us read about it. So children, in our activities we have used metal wires to make the circuit, right? And suppose we used a cotton thread instead of metal wire to make a circuit. Do you think the circuit will be completed or the bulb will light up? No children, if we use cotton thread instead of the metal wire, the bulb will not glow up. Why? Because cotton wire is not a conductor of electricity, right? We need some material which can conduct electricity, right? So let us now move ahead and further this discussion. So children, what are conductors? How do you define conductors? Conductors are the materials which allows the electricity to pass through them. Okay children, it allows the electricity to pass through them and are called as conductors. And so children, do you know that silver is the best conductor, and in fact it is the better conductor if we compare it with copper. But children, the problem is silver is quite expensive and we cannot use silver for each and every experiment that we have to carry out. So children, we use copper, so we mostly use copper as the connecting wire. Okay, so children, generally, and this is the conclusion that children, most of the metals are good conductors of electricity, and only a few non-metals such as graphite are the good conductors of electricity. Okay children, so let's move ahead. So children, what are insulators now? Now we have to discuss about the insulators. So children, the materials which do not allow the electricity to pass through them are called as insulators. For example, distilled water, glass, rubber, air and plastics. These are all the insulators, that is, they do not allow the current to pass through them. Okay children, so that is why insulator materials are used to make switches, electric plugs and sockets. Okay children, so the switches, the inside of these are made up of conductors, because obviously we would like to complete the circuit, but the outer covering of these is made up of insulators children. Electric wires, so rubbers and plastics are, which are insulators, are used to make the covering of the electric wires, plug tops or switches. Okay children, now children, we have an interesting activity for you, with the help of which we will be able to identify the different materials as insulators or conductors, and we call this setup as a tester. Right children, why? Because we are testing the different materials, whether they are insulators or whether they are conductors. So children, collect as many samples as you want, whatever you want to test, whether be it a pen or a pencil or a sharpener. You can collect as many objects and you can write them in the requirements. Then children, what we are going to do is, we will connect and make an electric circuit to test the materials, same as in the case of where we tried to make a switch and we connected it to a circuit. Right children, we are going to make a similar circuit. You can observe it with the diagram. What we have done, we have taken a cell with positive and negative terminal. We have connected one terminal to the cell, to the bulb, whereas the other terminal we have connected to the sample that we have to test. Here we will place the different samples and we will connect it to the other terminal of the bulb. Right children, for example, we start it by testing with a key, and you will observe, in case of the key, the bulb will start glowing. What does this indicate children? This will indicate that key has completed the circuit and has conducted the current, because of which the bulb started glowing. Right children, so we will make an observation table like this. In the first column we will write the materials, in the second column we will write whether the bulb will glow or not. Okay children, so children, in this observation table, so first material that we tested was key, and it turned out that bulb glows, so we can say whether it is a conductor or an insulator. So this will be a conductor, right? Then we will try it with a cork, and in case of the cork, the bulb will not glow, and so it is an insulator. Similarly children, you can carry out this experiment with all the objects that you have selected, and you can find out whether it is a conductor or an insulator. Okay children, so let's now move ahead. So children, we have written for you all the samples. For example, plastic scale does not help us to plastic scale, because of which the bulb will not glow and it will be termed as an insulator, and I am sure that you will be able to find the answer for all of the materials that you have selected. Okay children?
To find conductors and insulators of electric current from among common substances. Materials required: dry cell, sellotape, 3 insulated copper wires with bare ends, bulb with holder, brass candle stand, plastic mug, rubber balloon, steel glass, common pin, eraser, tap water, salt solution, kerosene oil, mustard oil, vinegar. Method: connect the bare ends of the copper wires A, B and C through a bulb with the help of sellotape. Touch the bare ends of wires B and C with one another. You observe that bulb glows, thereby showing that all the parts of circuit are conducting electricity. Touch the bare ends of the wire to brass candle stand, steel glass, common pin, an eraser, a plastic mug, a rubber balloon, one by one. You notice that the bulb glows brightly in the case of brass candle stand, steel glass and common pin. However, the bulb does not glow in case of an eraser, the plastic mug or the rubber balloon. It is because the former allow the electric current to flow through them and hence are called conductors. The latter do not allow the electric current to flow through them and hence are called insulators. Dip the bare ends of the wires B and C in tap water. Salt solution, kerosene oil, mustard oil and vinegar one by one. You notice that the bulb glows brightly in case of tap water, salt solution and vinegar. However, the bulb does not glow in case of kerosene oil and mustard oil. It is because the former allows the electric current to flow through them and hence are conductors. The latter do not allow the electric current to flow through them and hence are insulators.
So children, we have an interesting fact over here with you that our bodies have 70% of water by weight. Okay children, and that is why our bodies are good conductors of electricity. They are good conductors and that is why we can easily get electric shock. Okay children, and therefore we should never ever touch the electrical appliances either with wet hands or bare hands. We should always be careful with the electrical appliances. We should always wear rubber slippers while handling these electrical devices. Okay children, I hope that you would be very careful around these electrical appliances. So children, this is it. This was all about the electrical conductors and insulators, and I am sure that you would have understood the concept really well. Thank you so much for your attention.